Hello everyone, welcome to my YouTube channel. My name is Evidence, and in today's video I am going to show you how to create a pipeline for your machine learning models. So before we begin, I want to give you a little bit of a context. So in the last two videos, I showed you how to build a decision tree regressor model. And while I was building this model, I used one hot encoder to encode the data frame first. Then I built the model, and then I got a prediction from the model, and I got error metrics from the model. And that was the last two videos. And then in the last video, I showed you how to explain your decision tree regressor model. So basically, how to create a visualization like this that basically shows you which features in your data frame has the most impact in your model. So basically, for example, you could drop these features from your data frame because they don't have that much impact on your model. That's what I did last two videos, and that's what I did in the last video. In today's video, I'm basically going to take all of this and put it in a pipeline. A pipeline is basically a streamlined way of basically doing what I did above. So to begin, I'm going to show you my X-train data. And my X-train data is similar to my Y-train data. And as you can see here, my X-train data, we have a column called status, which is a category. And we need to convert this category into integer, all right? And before we get to our model. With other background information, let's go ahead and get started, and things will make more sense as we keep coding. So first, let's go ahead and import pipeline. So from sklearn.pipeline, import make pipeline. If you are in Jupyter Lab, VS Code, or anywhere else, make sure you install Sklearn first in your environment before you use it. I am working in Google Colab, so I don't need to install Sklearn first before using it. But if you're working everywhere else, make sure you have Sklearn installed. And quickly, we can look at the Sklearn pipeline documentation. There's nothing much here to look at. It doesn't have too many things. It does have a fit method, fit transform method, a score method, and it has other method that you can use. So let's go ahead and instantiate our pipeline. So let's just call it pipe. Why not? It's equal to make pipeline. And here in our make pipeline, the first thing we define is the steps, right? So in the decision tree model above, I did one hot encoding. So this is like the encoding step. And then this is the model. And if I had like other things I wanted to define, wanted to standardize the model, I could also add standard scalar here. Okay, so actually what I could go ahead and import it. I'm not gonna use standard scalar, but still I want to have it. Let's go ahead. Actually, let's go ahead and just add it. So let's do from sklearn.preprocessing import standard scalar. So the transformations we want to do to our data frames, we want to encode our status column from categorical to integer. We want to scale our data frame, and then we want to define the model we are going to be using. Let me go ahead and also import category encoders CE. So before I could do this, like earlier in this notebook, I had to do pip install. So before you use category encoders, make sure you install it first in your environment. And I know I keep saying to install stuff, but if you don't install stuff, then you're going to run into problems when you're trying to run code like this one. So before you use category encoders here for your encoding, make sure you install it first. But I'm going to comment this out because I don't need it, and I'm going to run this. And so here we are going to do one hot encoding. So we are going to do ce.1hot. And we're just going to use the default. Here I'm just going to use category names equal to true. So basically, anything that you would normally do step by step to, let's say, clean your data or to prepare your data for a model, you can do all of that stuff here in a single pipeline. And I'm just gonna do scalar is equal to, and this is where we will add our scalar if you wanted to have a scalar in your pipeline, if you wanted to scale your data. But I'm not going to be scaling this data, and I want to keep this very simple so I can compare the results to what I have above. And the thing is, when you scale your data, the results that you get might be different from what you have if you didn't scale your data. And for a decision tree regressor model, scaling is not necessarily needed. So here I basically say decision tree regressor. Yeah, and I'm gonna do random state is equal to 42. So basically random state 42, just make sure that whenever you run this model on your local computer, you kind of get the same results as me. So basically this is us instantiating our pipeline. And like I said earlier, you can add more steps here if you want to, but in this situation, I'm just gonna do 2 steps. So now we do tree.fit. We want to fit our X train, and then we want to fit our Y train. My Y train in this case is my life expectancy. My Y column is like that's the target is life expectancy in this data frame. We are trying to predict the life expectancy of individuals, like of a country, the average life expectancy of a country. Oh, I said tree. I said pipe.fit. All right. So now that we fit our model, and what you can see right here, so the first step was one hot encoder. As you can see, the first step was one hot encoder, right? And then, so it basically did one hot encoder step right here. And then after doing the one hot encoder step, it did the decision tree step. So if you wanted to add a scalar, it's very similar. Basically what you do here, you do standard scalar, parentheses, and then you run this. Oh, make sure you add your comma. And then you run this. And as you can see, the first thing that happened is we had the one hot encoding occur on our X train. And after the one hot encoding happened, we had the standard scalar applied to our X train again, and then we had our decision tree. So basically these steps that you'd have done individually, you can do it all at once using a pipeline. That's pretty cool. But like I said earlier, I really don't want standard scalar here because I want to get the same result as I did above, and also I want to get the same visualization. I didn't scale the data in the above tutorial, and I do not want to scale it here because I want the results to be consistent so we can compare and kind of show you that this works. So I'll just use it without the scalar like I said earlier. Run this, and then let's move on. So after we have run the model, the next thing is we can use this pipeline to do prediction. So use pipeline for prediction. And then we do whitebread, let's call it whitebread2 is equal to pipe.predict. And we want to predict using our S test. So after doing our prediction, we want to evaluate how good our model is, how good our decision tree model is. And in this situation, one way to evaluate a model is by using the mean absolute error and the R2 score. So when you're working with a regression problem, you want to use regression metrics. And when you're working with classification problem, you want to use classification metrics. So let's go ahead and evaluate our decision tree model. And we should get the same result like we did above when we did it without the pipeline. So let's call it, so before you do this, make sure you import. So from sklearn.metrics, import mean absolute error, R2 score. So make sure you do this step in your code before you get to this step. So mean absolute error 2, let's just call it 2, is equal to mean absolute error. And we want to provide our y-test, which is our true value. When you're working with mean absolute error, the first value is the true value. Then you want to provide your predicted value, and we call it y-pred2. And now we can do MEE2. As you can see right here, the mean absolute error that we get using our pipeline is 2.186. And if we scroll back up here, the mean absolute error that we got using our decision tree model without a pipeline is also 2.186. So as you can see, a pipeline doesn't really change anything about your model. It just streamlines stuff. It just makes it easier to do everything step by step. And let's go ahead and get our R2 score. So if you look at the documentation for a pipeline, you can see that it has a scoring metric, and this score metric in this example is gonna give us the score for decision tree. So a normal decision tree regression model has a scoring method that gives you the R2 score. So the decision tree regression model has a score method, and it gives you the coefficient of determination, which is R2 squared. So when we call the scoring method on this pipeline, is going to use the scoring method from decision tree regressor. That's what I've been trying to say. I hope that makes sense. So we can do pipe.score, and we can provide our S test and then our Y test. As you can see, our R2 score here is 0.88. And if we also use the scikit-learn metric, we will also get the same score. So if we do R2 score and we provide our true value, which is our Y test, and provide our predicted value, which is y-pred2, as you can see, we get the same score. So there are multiple ways to get the R2 score from a regression model. You can use the scikit-learn R2 metric, or you can use the built-in scoring method. And as you can see, the results we get here from our pipeline model is the same result that we got above without using the pipeline model. Again, pipeline doesn't change anything. It just gives you the exact same result as doing things individually. Pipeline is there for the sole purpose of streamlining your code. So now that we've gotten the metric, I wanted to show you one last thing. So in the previous video, I showed you how to explain a decision tree regressor model, and I created this visualization. You can also create this visualization from a pipeline model, but it's a bit more difficult and it's a bit more involved. So the next part of the video, I'll show you how to plot the feature importances from a pipeline model. So plotting the feature importance, like I said, is a little bit more involved. I'm just going to call it model, and I'm going to say that our model is pipe.named steps, and then here you do decision tree regressor. Okay. Now to get the feature importances from your pipeline, what you do here, then you do model dot future importances. So in order to extract the future importances from a pipeline, you define the named steps of the decision tree. So basically you pull out the decision tree step from your model, and then you get the future importances that way. And also let's say to get the columns from our data frame, you do the encoder is equal to pipe.named steps, and this time we want to do the encoder. So we want to pull out our columns. So after doing the encoding process, right, our columns change, right? So if I just do xtrain.columns, now if I do something like columns is equal to encoder dot transform as test dot columns, and if I do columns here, as you can see right here, when we do the encoding process, we create an additional column. So here in the training data, we just have a status column, but after encoding, we break this status column into two columns: status developing and status developed. All right, so that is why we are pulling our columns from the encoder step instead of pulling our columns from, let's say, just stest or just xtrain. That's because during the encoding process we created additional columns. So basically, right, these future importances correspond to these columns right here, and the next step is basically taking these columns and pairing them up with their corresponding future importances in a pandas series. All right, so just remember, to get your future importances, you pull out the decision tree step from the pipeline. To get the columns, you pull out the one-hot encoder step from the pipeline. So let's just call it combination. Why not? It's equal to pd.series. So pd stands for pandas. Earlier I did import pandas as pd. So pd.series, we want to combine our importance. We want to combine it with our columns. Here we can do combination to get a preview. As you can see, each one of these columns has been paired up with their corresponding future importance. That's basically what this step does. And now the final step is to visualize it. So now we just do combination dot sort values dot plot dot bar age. I want the color to be red, and let's just do pt.title. Now I'm able to do this because I have matplotlib. So before doing this right here, I did import matplotlib the pyplot as plt. You can change the size of this, right? Okay, so these are the two commands I did earlier in this notebook, which is what's allowing me to do this. And then I define the figure. So basically, figure is like how big do you want your graph to be. And I believe earlier I set it to 6x4. So basically here, what I'm doing is I'm taking this pandas series right here and I'm visualizing it. And first I'm sorting the values, then I'm plotting it because of matplotlib. I'm able to plot it. Make sure you have matplotlib in your environment first. And then I want a bar graph. I want it to be horizontal. That's why you see this age. And I want the color to be red. And this is the title. And right here, as you can see, these are the features that has the most impact on our model. And what we got here is exactly what we got here. Like this right here, when I did this, this is when I did the everything step by step. I did the encoding step first, then this decision tree first, and I got this result. And then I took all those steps and put it in a pipeline like this, and I got the exact same result. So in a nutshell, this is how you would use a pipeline. And if you want to pull out specific things from your pipeline, this is how you will do it. You use the named steps. So quickly right here, if I go ahead and run all of this again, but have a standard scaler in it, let's see what our result is gonna be. So actually including a standard scaler reduces our error. That's really good. Doesn't make actually it does increase our score a little bit. So scaling the data doesn't have much impact on anything we've seen so far. Let's see what our visualization looks like now. Yeah, same visualization, nothing has changed much. That's it for this video. That is how you use a pipeline to streamline your data science process. You can find me online at evidencen.com. This is my primary website where I create data science blog posts, and as time goes by, I am going to add more and more stuff to my data science blogs. And you can go to my free data science resources to get access to this notebook. So if you go to machinelearningeducation.com, you'll be able to get access to my free data science resources. You can just click on this and to take you to the same page, or you can just go to machinelearningeducation.com/free. So this notebook that I use in today's videos, and any notebook that I use in my future videos, can be found at machinelearningeducation.com/free. I create a lot of blog posts and I create a lot of YouTube videos, and I end up with a lot of notebooks, and I just found it easier to take all my notebooks and all my resources and put it in one platform, so you have one place to go to get access to all my notebook and all my resources. That's it for this video. Thank you for watching. If you have any questions, let me know in the comment section below, and I'll talk to you on the next video. Bye.